Welcome everyone to our What's New in SOLIDWORks 2014 series. Today's webinar is going to be on increased performance. My name is Matt Morgan. I'm an application engineer with GoEngineer and have been for about 13 years now, and I've enjoyed working with SOLIDWORks. I'm excited to show you some of the What's New topics of 2014. Let's jump into our PowerPoint and show a list of a few things that have been enhanced in 2014. A lot of enhancements have been added to graphics, and I'll just show this PowerPoint slide just to let you get an idea of some of the things that have been changed and how much improvement they have seen. On the bottom, you'll notice that the performance gains measured against SOLIDWORks 2013 using multiple customer data sets. So these are the results that SOLIDWORks found. Obviously, results may vary depending on different setup and assembly size and things like that. But these are some of the things that we're seeing. A lot of it is in graphics. A few things in performance. Even the section view has a graphics section that allows you to not actually physically cut the model, but just graphically show it cut. So that is one that you're really seeing improvements on, up to 12 times faster with those section views. And there's a lot more things as far as performance. SOLIDWORks is always looking at how to develop the software to take advantage of hardware better and faster and make things easier to work with. A lot of today's webinar is going to talk about more how they made tools easier to get to, so your design performance will be faster. Not all of it will talk much about how much your hardware is going to be utilized differently, but this screen is the one that really talks about that. So when we move on to the next section, we're going to talk about assemblies a lot in this topic. So we're going to cover some of the enhancements to assemblies and how to get your job done easier when you're working with assemblies. So here we have a few topics that I want to cover. The view mates have been enhanced. I'll show you that. And exploded views now include rotations and a few other things to make it a little easier to work with. So let's jump into SOLIDWORks and take a look at those things real quick. So let's see. Let's go into SOLIDWORks, and we have an assembly here. This is a shredder created by BPGWorks. It's part of the assembly of the shredder. But if you want to look up on YouTube, just look up BPGWorks, spelled W-E-R-K-S, and the shredder, and you'll find this device, at least part of it. It's actually a track vehicle that you ride on, kind of like a skateboard / jet ski / tank. So this is just the track assembly mechanism minus the track, obviously, but it would ride on these wheels. But we're going to use this assembly to show you some of the enhancements to the assembly. So first of all, I mentioned that the view mates have been enhanced. The enhancement has been that view mates now supports things other than just components. In the past, you could only view mates on a component. Now you can see I can look at the top plane and see what mates are attached to the top plane, or even sketches. I can pick on this sketch and show the view mates function and see what mates are associated with that sketch. Even so far as to go into features, I can just hit the tab key when my cursor is on a part and have it hide that part. I can zoom into it with the G on the keyboard for magnifying glass, and I can pick this face. And in a right-click, there's an option to find it in the tree, so I can go pick just the feature, not the component. And then I can say View Mates, and I can see what mates are associated to that feature. Now, this can really increase your performance or help you when you're trying to figure out how to simplify a model to be able to put it into a really large assembly. You know, if I'm trying to remove little extruded text or fillets or things like that, I can find out if removing or suppressing those features is going to affect any mates in the assembly. And so it's a really easy way to just find if there's anything mated to a feature even, so when I start suppressing things, it's not going to have an effect on those features. Okay? Now, the second thing that I wanted to show you is the exploded view. So I'm just going to jump up into creating a new exploded view and show you some of the enhancements to the exploded view. The enhancements mainly are that I can add rotations now, not just translation only. I can add a rotation to it. And they do have this option over here on the tree in the property manager to rotate each rotate about each component origin. So as I rotate one, you can see that both of those nuts are rotating at the same time. And we'll just drag that rotation around. See if I can get it to go up to 360. If I pass it, then I have to go back around. But I'll just bring it up so it rotates about 360 degrees, and then I can pull it out, and both of those things will happen in the same step. So as we'll see in animation later, that they will both rotate and translate it out at the same time, giving you some advanced ability to animate and show how your assembly collapses and explodes. Especially when you get into components that you need to show that maybe they assemble then twist into place. You can do that real easily. And in 2014, you don't have to hold the Alt key to drag the triad around anymore. You can just drag it. So I can drag it, drop it here, rotate this part up a little bit. Oops, got that on the wrong rotation plane. Let's do that again. So let's pick this assembly. I'll drag it right onto this edge. Then we'll rotate it. That's more what I wanted. So let's rotate it about there, and then we'll start another step that just pulls it out. So now if I animate that collapse, you'll be able to see the effect. It allows that to rotate in, and then the nuts screw on. Gives you kind of additional options as far as creating explode views that make it even more easy to describe how an assembly needs to be put together. You can show nuts turning. You can show things that need to come in first and then rotate into place. That kind of stuff can really help with your explode views. All right, so the next thing I want to show you is the easy access to configurations. If I just pick on a part, then the pop-up tool pops up and gives me access to configurations right here. I don't have to go into component properties anymore to get the list of configurations. So we can right-click, select subassembly, and find the subassembly, and quickly change its configuration to show the retracted version. Okay, that, and that brings it up to the retracted version. We'll select the subassembly again and switch it to the free. And then also the access to the flexible assembly option is also in the pop-up tool now, instead of having to go into component properties to make something flexible. So I can make this assembly flexible. In 2014, they also changed some of the flexibility code, so it behaves a little more predictably. You know, they've worked on that several times in the past releases, and they made a few changes to that again to make it behave more accurately. Where both of these are the free configuration, they need to both be able to move free independent of each other, even though they're the same configuration. So it's been a little bit difficult, but SOLIDWORKS has made some improvements to make that behave more predictably. Let's take a look at the ability to select. Again, when you're talking about large assemblies, it's very common to want to get rid of small bolts. You know, in this one, it's not very big, but if you have, 10,000 components, 20,000 components, you're going to have a lot of little tiny features that you might not even be able to see when you're looking at the overall assembly. So being able to quickly select those small components can be very helpful. So I can say select by size. It's a new option. In the past, you had the ability, if you went into advanced select, and you could select based on mass, and you had to pick some number. But the nice thing about the size box is that you can just drag it until you say, I kind of like it about maybe there, where it's just picking some of the smaller features, the smaller nuts, bolts, washers, anything that's small enough that you wouldn't really notice them when you're looking at a 20,000 component assembly. And that would vary with each assembly. So you have that ability to just quickly hide. You can hide or suppress or whatever you want because it selected all those little tiny components. You also have the ability to pick in the graphics area. And you'll notice that when you select things in the graphics area, it highlights in the tree. But when you pick things that are at different points in the tree, it scrolls down to that location and highlights it. But as soon as you unselect it, you'll notice now in 2014, SOLIDWORKS will automatically go back to where you were scrolled to before. So if I scroll to the bottom, I pick something that's closer to the top, and then I unselect it, it goes back to the bottom when I'm done selecting. If I scrolled up to the top, it goes back there. So the feature manager scroll behaves a lot more predictably now, where when you're done with your selection, it will go back to where you were scrolled to before. That could save you a little bit of time having to zoom around, try to find stuff in your feature manager. Just for a little tip too, Shift-C is a quick way to compress all the objects in your feature manager. So if you just hold Shift-C, that's a default keyboard shortcut to just compress it, to collapse everything in the tree. So that could be a nice tool as well for that. And that one's not new, but it's handy. Let's see. The next thing I want to show you is the Assembly Expert. If we go to the Evaluate tab, the Assembly Expert has some enhancements to help you interrogate your assemblies, to help figure out where you might be able to make the most changes that will affect the performance of your assembly. So the first addition to 2014 is the ability to look at the rebuild time of your assembly. In the past, they have kept that out because it's fairly difficult to figure out how much time is rebuilding, where it's rebuilding each mate and solving all these things at the same time. But they added that capability to see the whole rebuild time. They also added things like virtual components, how many virtual components you have in your assembly. Sorry, I want to highlight just those. And envelope components. Those are not new tools, but the ability to see those tools is new in 2014, as well as the number of flexible mates being solved. When you make a mate flexible, or when you make a subassembly flexible, it basically has to solve the subassembly's mates now at the top level assembly. When it's rigid, you get a better performance because it doesn't have to solve those mates. So being able to see how many of those mates are solving will let you kind of interrogate whether you need to switch back to rigid assemblies instead of flexible, so it doesn't have to solve for as many mates anymore. So the Assembly Expert just has a few more things to help you interrogate your model. What do we got next? We have the mirror tool has been enhanced. If I look at our PowerPoint again, let's show the slideshow, and we'll look at the next slide. We have our some of the things that I showed you, the quick access to configurations, the flexible switch is easier to get to in the pop-up toolbar, and it behaves more predictably. You have the select by size, improved scrolling. Assembly Expert has a few new enhancements to it. If we look at the next slide, we have mirror components. Some of the enhancements that you'll see are when you mirror a group of components, any mates that were mated between those components that you're mirroring will get copied. But in the past, it wouldn't copy any of your advanced or mechanical mates. So they have enhanced the mates that will get copied when you mirror a group of components. If you have any of these mates in between those components that are being mirrored, they will be copied as well. Also, this new option to mirror about a bounding box, which can save you a lot of time. If we take a look at that real quick, let's just switch over to SOLIDWORks again. What I'm going to do is just show kind of the old functionality. If I go to my view and show the center of mass, that shows the center of mass of these subassemblies that are basically these crossbars that are holding these wheels. So if I look straight down those, you can see that those the center of mass marks are lined up with each other. That's traditionally how the mirror tool has always worked, is that it mirrors about the center of mass and then puts it on the other side of the plane symmetrically. But what happens if we select one of these components and say, let's unsuppress one that would make it no longer symmetric anymore? What you can see is if I look straight down this again, the center of masses are still aligned even though we don't want them to be. What you can see is because the center of masses are aligned here, we're not getting alignment on our bolt holes. You know, the bolt's over here, the hole's here, it's supposed to be lined up there, but because it mirrors around the center of mass, it's not lining it up correctly, and you'd have to take the time to go fix that. So what we can do now in 2014 is edit that mirror feature and go into the screen here and say, use a bounding box instead of the center of mass. You have the option to use either one. You can see the results. If I switch it to bounding box, it's going to move that over to where it's mirroring around a box that's drawn around the whole part. So it's drawing around the center of the bounding box instead of the center of mass. So if the center of mass is not truly symmetrical, then mirroring around the bounding box will give us a better result. So I'll go ahead and just suppress this guy again, bring everything back to order. But you can use that bounding box. Oh, by the way, there's this part still hidden. Just remember, you can tab to hide a component and shift-tab to show it again. Okay. There is some options too in your options here under. Let me think of where it was. It was View. That's where it is. In View, you have the option to hide show component and make it fast or slow, or just immediate. And I've switched mine to immediate, so they just show and hide instead of slowly fading away. I like to do that. But you have a lot of control on what hides or shows, what kind of adjustments you have. There's a couple other things. I'll show you some options that give you some adjustment tools as well. So let's close this one and jump into another example. This one takes advantage of some new patterning tools in 2014 in an assembly. In parts, we had these tools, these types of pattern styles, but in assemblies, we didn't. So now in 2014, we have things like the sketch-driven pattern, the curve-driven pattern, and they also renamed what you may recognize as feature-driven pattern. It has now been renamed to pattern-driven pattern, just to make it a little bit more understandable on what it's doing. It's a pattern-driven component pattern, and I'll show you that one too. So let's start with the curve-driven pattern. Basically, what we have here is a bunch of chain components, and they are different. You know, some of them have a hole, some don't, so we couldn't just pattern them all together. But what we can do is use this sketch in the assembly to pattern these components and just use an equally spaced setting to get those patterns. So what I'm going to do is select Other, so I get the whole sketch instead of just the spline only. So I'll get the whole sketch here. I want 24 of these that are equally spaced, and I'm going to pick the components that I want to pattern. So it'll be this support here as well as the chain link. And then we'll just adjust some of the settings to say we'll offset the curve, so it offsets to this kind of the center of these, and then we'll rotate them tangent to the curve, so that gets them all in the right position by offsetting the curve to the center point and then rotating them tangent to the curve. And so real quickly, instead of having to go through and mate every one of these chains and put any kind of angle on them or anything like that, we can real quickly just use a pattern to create the chain. Obviously, you can't drag it around and have it move, but you can quickly show those chains easily with that curve-driven pattern. And then we'll take a look at our pattern-driven pattern. We're going to highlight that just because its name has changed, but it's not a new functionality. We've had that in the past. So we want to pattern this component as well as, actually that's all we want to pattern. And then the pattern we want to use is the same one as this one. So if I just pick that one, because that one was patterned, it's actually this one was the seed, and that was a pattern feature, it uses the pattern that created that. So that's a real quick way to get to it. You could also just use your tree and browse down to the pattern feature, but that way I can just pick that pattern instance. Now that brings up another new enhancement to 2014 is the ability to recognize which one of the pattern is the seed and which one is the pattern instance. The seed being the initial part, and then the instances, the pattern copies. So if I pick on a pattern, you can see they highlight in different colors. I think the default highlight is green, but I've changed mine to blue. But the pink is the seed, and the green in most cases, or blue in my case, is the pattern instance. Okay, so it allows me to real quickly create these types of assemblies just by using that curve to pattern all of this around and create a nice chain-looking part that might be a conveyor system or something like that. Let's take a look at patterns in parts. There is one little enhancement here that just makes it more flexible. If we look at a pattern in a part feature, let's say we were going to increase the pattern numbers. You can see they're touching now, and I can increase it to where they're overlapping each other. In the past, this would just fail. You couldn't create a pattern like this. In 2014, I can just say OK to that, and it acts just like a cut that cuts through a part and splits it into multiple bodies. It does the same thing. I get this bodies folder, bodies to keep. So I can say, hey, I want to just pick which bodies I want to keep, and I can say, let's just pick a few of those bodies, skipping a few of them. And you can see that it kept all the bodies except for the ones that I selected, or I left unchecked. We can edit that and just say, let's allow it to keep all bodies. And then every body is kept. So even though we patterned it where they crossed, we can still utilize that pattern and let it keep the bodies that it's kept. So these are now just floating out there in space because we kept them still, even though the pattern would have split it into multiple bodies. Okay, now let's just mention a few other things here. Sorry, let's go to the actual slideshow. So we had some enhancements to mirror. A lot of the mates and the bounding box was nice. The patterns in assemblies have some new options, and support for pattern and parts where you create multiple bodies allows you to keep those. In assembly mates, there's a couple things that I'll show you. As far as the SmartMate tool, there's a SmartMate button that you may not even have ever noticed before, but it's a little bit easier to get to now. Some default mate behavior has been changed. A few things that just make it a little more consistent with other types of tools. So let's just jump into SOLIDWORks again and show you some of those. So this is the one I want to show you yet. Let's go to, oh, I didn't open it yet. Let's go to Mate Mania. There you are, Mate Mania. So this one's going to show a bunch of different mate options that we have for creating mates. First of all, if you're familiar with SmartMates, you hold the Alt key down on your keyboard and you can drag something around. And in the past, everything that you put your cursor on, it would try to mate to as you're moving. So if I moved across this whole part, it would try to snap to all these holes. But what you'll notice in 2014 is that behavior is a little bit different. They tried to make this behavior available in 2013, but it was too slow and it took too long to get the mate to solve, so people didn't like it and they just took it out. And in 2014, they added a drag handle to say, well, if it's off, that would behave like it did before. If I set it to slow or fast, then it will actually give me some time in between, so I can move around and it doesn't snap to anything until I pause on it for just a second. Then it mates into place. So that gives me a little bit of time. I don't have to sit and wait for it to go to every edge that it saw until I get to this one. I can just pass over it, and then I pause on this one for just a short period of time, depending on how you drag that slider around, and it will mate into place. Now, the SmartMate component, the SmartMate tool, the first SmartMate that SOLIDWORks ever introduced was in the Move Component tool. It was right here, and it's kind of hidden. You have to go into Move Component and then pick SmartMates to get that to happen. In 2014, they made it so it's an actual button that you can put on your assembly. So I can just search my command search for Smart, find the SmartMates, and just drag that button onto my toolbar. Now I can take advantage of it. The nice thing about the SmartMate button is that, you know, when you're Alt drag and drop, you can't really rotate unless you use your unless you hold your left button down and push the wheel with your middle mouse button, and it takes a little bit of coordination to do. With the SmartMate tool, I can rotate around. I can pick on a face. You know, let's do the cylinder first. So I can pick the cylinder to cylinder. Double-click this face, and that activates the SmartMate, and then I can pick this face to put it into place. Put the rest of these on these screws, these bolts. Okay, now let's just go into the regular mate tool and take a look at a few enhancements that are in the mate tool. It's basically the default behavior has been enhanced. If I pick these two edges, they can't go coincident because of the other mates that are in place. So in SOLIDWORks 2014, it's smart enough to know, well, if I can't go coincident, let's try parallel. And it seems like the obvious solution, so SOLIDWORks went ahead and put that into place. If coincident doesn't work, then it defaults to parallel, and you don't have to change it to get it to work. And it doesn't pop up the error that says, I can't go coincident, I'm 29.7 degrees apart. You know, it gives you the nice parallel relation. So that's really handy. Also, when it comes into adding some of these mates like this one, when you pick an axis of an object, you know, maybe I don't have a cylinder to make concentric to, so you use an axis. If I pick this axis and pick a cylinder, in the past it used to default to coincident, which seemed like, why would you ever do that? Most of the time, if you're going to pick an axis, you're going to make it concentric to a cylinder, not coincident to it. So they changed the default behavior to be concentric by default, coincident if you change it. So now you have to change it to coincident, but it goes to concentric by default, which in my opinion is way more common to do concentric than coincident. So that's a nice enhancement. Also, with the pop-up toolbar that you get here, SOLIDWORks added some enhancements there. I can pick, control select two cylinders, and the pop-up dialog box gives me the mate tools now, some of your most common mates. So now I don't have to even SmartMate or turn on the mate tool. I just control select just like a sketch. When you're in a sketch, you can do the same thing. You control select and you get the relation options. Now you get the same behavior in an assembly. So I can just say control select two faces. The pop-up tool gives me those mate options, and I don't even have to go into the mate tool. I don't have to try to use the smart mate or anything like that, I can just pick those two faces. So let's just say this face, and I'll use select other, pick through this face to that one. And that doesn't look like I got the right face. Let's do it again, select other. There you go, that's the face I wanted. And I'll make that coincident. So a lot of things that have really made the setting up your mates and getting those working fast and easy to access have really been nice enhancements to 2014. Another one that when we did our rollouts, a lot of people really loved these new mating tools as well, the slot mate. That's a great mate tool. If I just activate the mate tool and go to the mechanical mate section, I have a slot mate option. In the slot mates, I have the ability to pick on a cylinder and a slot, and it mates it into place. And I can drag it around, and you can see that it automatically stops at the center point of the circles on the ends of the slot. So it automatically sets the limits to be within that slot, which is nice. I can also change it to other options. I can make it a center mate. I can make it a distance along the slot. I can make it 10 millimeters and make it either side. I can go percentage along slot and say, let's just put it at the 35%. Puts it exactly where you need it to. Or you can just keep it free and let it move around however it needs. You can also mate, it doesn't have to go in the slot, so this washer, the two cylinders, can be mated with the slot. You can even use the axis of an object. So this one that doesn't really have a cylinder, you can still use that axis and apply a slot mate and put that into place. You can also mate a slot to a slot. So if I pick on this slot and this slot, it will mate the slots together. And so now I can drag those around, and you can see the range of motion is based on the slot positions. You can also allow those slots to be center. When they're slot to slot, you only have free or center in slot options, but those are still great choices for the slot. Otherwise, it wouldn't know which way to go, which one to do a distance on. So I can mate those. You can see over here that you can mate a concentric slot as well. So it's not just straight slots. You can also do concentric slots where you have arcs. Basically, anything that you can create with the slot sketch can be mated with the slot. Or there's also new tools in the hole wizard to create slots in the hole wizard. So you'll check that out. That's probably in one of our other series. But you can see that these slots work together, and even the screw inside them is moving with the slot mate, so it behaves as though there was really a bolt in the slot there. So that's pretty handy. They don't have to be in flat faces either. This slot is in a cylindrical face. You can see that it still works inside there. A couple limitations to the slot mate are illustrated here. First of all, the slots have to be either an arc slot or a line slot. So the two lines, these two faces would have to be parallel or concentric circles. And at the end of the slots, they need to have equal radius arcs at the end. So this one would not work because there's a flat face. This one would not work because there's two square faces. This one won't work because it doesn't have the face at the end. It has to have the full enclosed slot for it to be able to work. And it will not work on cam slots like this. For these types of slots, you'd still have to do some kind of mate to a tangent, mate it tangent to a surface or something like that, which does work. It's just not as easy and slick. Okay, so slot mates have been enhanced. Those are pretty nice. A few other things that help with performance is how to access some of these tools. Oh, I wanted to mention too, I don't have time to show you, but the sphere mate has been enhanced too, where it has a lot more options for sphere mates. The sphere mate can mate to it can be tangent to a non-planar surface, edge, or sketch. So there's a lot more places that spherical mates will work. So that will come in really handy as well. As we mentioned, the slot mate. Plastics has some new enhancements too. The wizard, there's a runner system wizard that helps you design runner systems quickly. The results advisor helps you get through that really quick, and you can calculate the effects of residual stress. So kind of running out of time here, but let's jump into SOLIDWORks and just illustrate that real quick. So let's jump into a version that just shows, I mean, this is an iPhone cover. It's going to be injection molded with an ABS plastic. We want to see the results of the flow of the plastic as it is injected and predict whether it will short shot, where weld lines would be, air pockets, and that sort of thing. So let's turn on our plastics add-in. And just like our other simulation tools, it's a tool just adds a tab right inside your SOLIDWORKS screen. And let me do that again so I think I hit to keep those options, keep the old ones done. So let me reopen it so I can tell it not to keep the plastic results from before. There we go. I'm going to hit no to that. And go into plastics, and then we'll take advantage of the wizard, which can really help in getting started when you're new to plastics and need to know how to set this up. So I can pick between a solid or shell mesh. It walks me through the interface to really help me pick those. I don't want to use the previous mesh parameters. I want to create them new again. But I can just say, let's create a triangle size of 10 millimeters, automatically refine it locally. And so you'll see the refinement around the small fillets and thin wall parts. It automatically refines it really nicely for you. So we'll just accept all the other options as far as interrogating how the mesh worked and how what the quality of it was. Let's pin this down. So now the mesh is completed. I can go next. We can look at the material. We have something like 6,000 or so materials in here from different suppliers. You know, ABS is one of the larger material library sets, but we have different combinations of ABS, polypropylene, all kinds of other plastics in here that already have all the material properties. So we'll pick the generic ABS. When we're looking at the fill, we have this nice fill setting that just puts all the fill settings all in one screen. So we can kind of specify the temperatures and filling time or let it automatically calculate. We can even go into more advanced properties like fiber injection calculations, so you can determine orientation, if it's glass filled or anything like that. So we'll next through that, we can add the injection location. So we'll just pick a spot in here, take a look at, put the injection location there. And next, and now we could run the simulation. I'm going to go ahead and stop here and look at the results. It takes about 3 minutes for my computer to run this. So I'll just show you the results instead of making you watch the run time. Oh, before I do that, though, let's take a look at the runner design screen. I have this runner design wizard, and you got a bunch of different runner styles, you know, the submarine gate, the banana gate, maybe even a multiple injection part. I can just pick on that and pick the injection points, and it automatically builds the screw, runner, and gates for the system that I picked, whatever I pick here. And then I can use that for the injection and look at the fill with those multiple systems. So that's a real nice help. Instead of having to draw sketches for each of those, you can have it automate that process to make it nice and easy. So let's jump into our results. This one I do want to keep. So we'll look at those results. And we'll just load the results that I ran before. And we can then animate the filling of that. We can even hide the solid so it just shows how it fills inside there. It looks pretty cool. But it really gives us the time it fills. We have this nice wizard that tells you whether it will fill successfully or not based on the pressure required, but the simulation figured out. And it gives you all kinds of information on why it works well. And if it failed, it would give you information on what you need to do to improve it, what the reason of it getting a red light or a yellow light would be. And then fill time, there's all kinds of information here for the new guy that doesn't really know all the nuances of injection molding, can learn all about it really easily with this wizard. You know, a lot of companies that do injection molding will have a guy that's been doing it for 20 years that just knows all this stuff. But what happens when he leaves the company, or what happens when a new guy or even your engineer or designer needs to start figuring some of this out, to not have to always be consulting with that guy. He can learn all this stuff with the tool and predict the filling process, predict pressure, shear, temperature, cycle rate, sink marks, all kinds of stuff. There is a professional and a premium version of plastics. You can talk to your account manager to find out what each of those have, or even on SOLIDWORKS website, there's a matrix page that will tell you what each one has. But we can take a look at where weld lines would be, where air traps would be, where we might need to put vents or ejector pins, things like that. But a new thing in 2014 also besides the wizard, this is the result advisor isn't new, but the wizard to help you get it set up is new. And also there's an option now to export your results for your in-mold residual stress, and you can export it to simulation. So if you have SOLIDWORKS Simulation Premium, you could take advantage of this export file. I'll show you what that's like. If I go into our simulation tool and turn that on, we'll see a study that's already been run here. But basically, when you have a nonlinear solver, you can go into your properties of the study and add in that file that I just had. It's in a different path than where it was pointed there, but I have that file already imported and ran. And one of the options I should have pointed out there was that it can include the material properties from plastics. So I don't even have to go find the ABS material stress strain curve. It can bring it in because plastics has all that information in it in order for it to really determine how it fills. So now I can take a look at those stress results. If I zoom in and animate those, you can see how it's shrinking. If I exaggerate that a little bit, I can, let's say, exaggerate it 5 times so we can see a little bit more. You can see it also is bending a little bit as it's shrinking and warping a little bit. And that's really what this is trying to allow you to analyze, is what the warp effects will be on your part. So let's animate that real quick. But with the Plastics Premium and SOLIDWORKS Simulation Premium, you have the ability to do these really complex warp analyses and things like that to really predict what your part will do and be able to make design changes to make it warp the way that you need it to, or minimize the warping. One last thing that I want to show you, it's basically the CircuitWorks and Flow, some of the new enhancements to those tools, and then we'll be done. I'll open the floor to some questions if you want to add them into the chat window or the questions screen. I'll read through those and answer any questions that I can at the end. So let's jump back into SOLIDWORKS and take a look at the way that the CircuitWorks integration works. So let's turn off plastics and simulation now. I don't need them anymore, but I am going to show CircuitWorks and Flow. So inside CircuitWorks is basically a tool that allows you to import geometry from a PCB design in a product like Altium or Mentor Graphics or something like that that will do the electronics design. You can import that data into SOLIDWORks and be able to utilize that to build casings around or whatever is housing the circuit board. The component library can be, you can add files to it, but in the past it's been a little bit of a difficult process. There was a wizard for it, but you kind of had to do it one at a time. What I'm going to do is just delete my whole library and just show how this really increases the performance of your setup of your library and all that kind of stuff. So my library is completely cleaned up, and now I'm going to use this option to export this assembly into CircuitWorks, so it'll take advantage of these shapes instead of just taking the generic outline that's in an IDF file and extruding it to the height. It will actually put these components with their more accurate shapes in. So I can basically just pick the circuit board, and let's pin that down so it doesn't keep hiding. Pin the circuit, or select the circuit board. Next through, basically it's looking at the outline. There's some sketches that it can use to help determine, the plated hole features, non-plated hole features, outline, any of that kind of stuff. And then it creates the file. When I hit finish, it puts all of those components into my library with their actual shape and orientation based on how they're defined on this circuit board. And it's building my library. So if I look at my component library, you can see that it's starting to put stuff back in there. And once it's done, it will then open it in CircuitWorks, and I could save it back out and even send it to our electronic engineer that might use it to help make traces. If I'm highly involved in placing components to make sure that the casing that I'm designing fits around it, I might give them some basic component placements and then see if they can utilize that to design the traces and all that. But if I open that in CircuitWorks, you'll also see that there's a few enhancements to CircuitWorks. First of all, I can zoom, pan, and rotate now, which I wasn't able to do in the past. So when you're looking at these little tiny resistors and things, it's a lot easier to see those now if you can zoom, pan, and rotate. I also have some tools to filter out small components and things like that. Properties can now include thermal properties. So if I pick one of these that has some thermal properties, you can see that those thermal properties are filled out. Now, where flow comes into play is flow is a great tool to help determine the thermal properties of these parts when you have chips that are generating heat and fans and all kinds of stuff like that. SolidWorks is a tool that really helps determine what the thermal properties are. If I take a look at the flow tool, there's some options in here to import the data from the model so that the thermal properties and material properties that were defined already in SolidWorks or CircuitWorks, you can just import those. And if I go to my flow tab, you can see it's building all of those libraries of components. So I have all the components and their material properties, all of them that are set to copper and all the different material properties. And then I have the heat generation rate for each of the components as well. So I can just basically set up some goals and run it, and it's already all set to show the thermal properties. And the runtime on this one takes, again, I think this one takes in the 3 to 5 minute range. So I'll just take a look at an e-drawing that has the results already done. And I'm picking an e-drawing because there's some new enhancements to e-drawings as far as the flow analysis are concerned, which is the ability to show multiple plots at the same time. In the past, you could make an e-drawing of one plot at a time. Now I can combine the cut plot. I can hide and show each one individually. So you can see I have a surface plot of the temperatures. I have the flow trajectories showing these curves. And then I have a cut plot. And all those can be created in one e-drawings file now, which is nice. So this is the results of what I imported right from the CircuitWorks file and brought into flow and ran the flow properties of this. I'm guessing there's a little bit of a fan based on just the way that this flow is moving up here, but there is a little bit of air blowing across here representing a fan to help remove the heat. So that gives you very accurate thermal properties as well, being directly imported from the CAD model or from CircuitWorks if it's defined in your electronic PCB design software. So that is our webinar for today on increased performance. My name is Matt Morgan again. If you have any questions, you're welcome to email me at mmorgan@goengineer.com. And we also have our tech support that you're usually used to using and familiar with. So feel free to get in touch with our tech support team as well. If there's any questions, I'll go ahead and take them now. I'll see if I can read through them on the question box if there is any. We had one question. Can we get a copy of this webinar for later reference? Yes, it will be posted on our website. Probably take a few days for me to get the recording to our marketing team so they can post it on our website, but we will definitely have a copy of this available in our webinar section on our website. So if you have any other questions, go ahead and ask them. I'll remain on the line for a few more minutes. I'll stop the recording of the webinar, but if you have any other questions, feel free to ask them, and I will answer them as they come. Thanks again for joining our What's New in 2014 series on increased performance.